Hi GOR, this is Unit 6, Lesson 5, and today we're going to talk about angles of elevation and depression. So first example I have, from a point 120 meters away from a building, Serena measures the angle between the ground and the top of the building and find that it measures 41. All right, so this angle right here on the ground is 41. What's the height of the building? That's the thing I'm trying to find. So that is going to be, they actually called it Y. All right, so this is my building right here. They put the Y on this side, but the Y could certainly be on this side also. So basically this is opposite, and this 120 right here is adjacent. So I'm going to use tangent. So tangent, the angle comes next, and I know the angle. Tangent of 41 equals opposite over adjacent. And then I'm going to put a 1 under this. I'm not trying to find the angle I know, so I'm going to use my regular tangent button. I put a 1 under this, cross multiply, 1 times y is y, tangent of 41 times 120. Now when you do this in your calculator, make sure your calculator's in degrees. You hit tangent 41, close the parentheses, and then times 120. All right, and that will give you 104. All right, so that's a problem we've been used to doing. Let's talk about these two new words, angle of elevation and angle of depression. Angle of elevation. The angle of elevation is always measured from the ground up. It is an upward angle from a horizontal line. It is always inside the triangle. You can think of the angle of elevation in relation to the movement of your eyes. You are looking straight ahead and you must raise or elevate your eyes to see the top of a tree. When trying to remember the meaning of angle of elevation, think of an elevator that only goes up. So your angle of elevation, okay, new word, is always here in the bottom corner of the triangle. Okay, it's on the ground. It's basically you standing here and you're looking up at something, like something at the top of the tree, a bird or something like that. So the angle of elevation is in the bottom corner of the triangle. Another word is angle of depression. So angle of depression is actually outside of the triangle. The angle of depression is always outside the triangle. It is never inside the triangle. It is a downward angle from a horizontal line. You can think of the angle of depression in relation to the movement of your eyes. You are standing at the top of a lighthouse and you are looking straight ahead, and you must lower or depress your eyes to see the boat in the water. So the angle of depression is technically outside the triangle up here at the top. Okay, but here's the thing. These are parallel lines, so your angle of depression can also be in the bottom corner also, because those are alternate interior angles. All right, so angle of elevation is in the bottom corner of your triangle. Angle of depression is technically outside of the triangle at the top, but because these are alternate interior angles and alternate interior angles are congruent, you can also put it in the bottom corner of your triangle. All right. So that sort of answered our next question. What do you think is true about the relationship between angle of depression and angle of elevation? They are the same. They are the same because alternate interior angles are congruent. So you should know the difference between them, but basically they're both just going in the bottom corner of the triangle. So I got 3 problems that we're going to try with that. All right, a man standing on level ground is 1,000 feet away from the base of a 350-foot tall building. All right, so I'm going to draw myself a right triangle. A man on level ground is 1,000 feet away from the base of a 350-foot tall building. So you got to think about where everything's going. The building is obviously this vertical line right here, and it's 350 feet tall. A man, so basically I have a man sort of standing out here, and he is 1,000 feet away from the base of that building. And they want me to find the nearest degree, the measure of the angle of elevation. Angle of elevation goes in the bottom corner of my triangle. Angle of elevation goes right there. All right, this is, let me get a different color. This is opposite. This is adjacent. So I'm going to use tangent. Just going to write this at the top of my paper right there. So I'm going to use tangent to figure this out. So tangent of x equals 350 over 1,000. Now, I don't know what the angle is. Whenever I don't know the angle, I have to get rid of that tangent. The way I get rid of that tangent is I do the inverse. So it's second tan, so I get tan negative 1, 350 divided by 1,000. Okay, and that gives me, do that in your calculator, make sure your calculator's in degrees. Second tan, this is exactly what you're putting in, second tan, and that inverse button pops up. And then you're going to just do 350 divided by 1,000. And you will get 19 degrees because I'm doing it to the nearest degree. All right, so make sure you can do these in your calculator. All right, next one, number 3. A person measures the angle of depression from the top of a wall to a point on the ground. So again, I'm going to draw myself a right triangle. This is the wall. So from the top of the wall to an angle on the ground, that angle of depression is, do they tell me what it is? The point is located on level ground 62 feet from the base of the wall. So this is 62 feet. And the angle of depression is 52. Perfect. So technically, my angle of depression is outside the triangle. All right, so you're basically on top of this wall. You're a person up here looking out. And the angle of depression is technically outside the triangle, but I can't do trig unless I put that angle inside the triangle, so I'm going to put that 52 degrees in there. And how far is a person from the point on the ground? So I'm trying to find this hypotenuse right here. The person's up here on top of the wall. How far are they from the point on the ground down there? So, based on this angle of 52, this is adjacent, and this is hypotenuse. So because it's adjacent and hypotenuse, I'm going to use cosine. Cosine, the angle comes next. Cosine of 52 equals adjacent over hypotenuse. Put a 1 under here, cross multiply. Cosine of 52 times x equals 62. Now I have the angle, you're not doing the inverse. I want to get rid of this whole expression, cosine of 52, so I divide by cosine of 52. Divide by cosine of 52. So in your calculator, you're going to do 62 divided by cosine of 52. And I want my answer to the nearest tenth, 100.7. Right? And the last one. Scott, whose eye level is 1.5 meters above the ground, stands 30 meters from a tree. The angle of elevation of a bird at the top of the tree is 36 degrees. How far above the ground is the bird? Here's the different. This is a little bit different because I am making a right triangle with Scott's eyes. Okay, so here's my right triangle. He is 1.5 meters above the ground, his eyes are at least. He stands 30 meters from a tree, so this is 30. He's 30 meters from the tree. The angle of elevation, which always goes in the bottom corner of my triangle, is 36 degrees. How far above the ground is the bird? So this is going to be my x right here. All right, so I'm going to do, this is opposite and adjacent, so I'm going to do tangent of 36 equals x over 30. Put a 1 under this, cross multiply. 1 times x is x. So I got tangent of 36, close the parentheses, times 30. That whole thing is going in your calculator. All right, that's not going to be my answer though. So this gives me 21.796. So basically this right here is 21.796. But I technically want how high is the bird above the ground. So I just figured out from here up is 21.796. But remember, Scott's eyes were 1.5 feet from the ground. So I'm going to have to take the 21.796 and add on 1.5. So this is definitely a little tricky. And I want that to the nearest tenth. Okay, because the right triangle did not start at Scott's feet, it started at his eyes. But I want to know how far above the ground is the bird. Okay, not how far the bird is from Scott's eyes, all right, but above the ground. All right, and we will practice some more of the angle of depression and angle of elevation.